Hey channel, Fernando from SkyFi Audio. Today we're going to have some fun with these two Technics turntables that I've set up right here. We've got an SL-1200G and an SL1500C, and we're going to test them for their capabilities for both absorption of vibration and electronic interference. So we're going to, I've sort of set up this rig here where we're going to vibrate this table at 40 Hertz, and we're going to measure it using an accelerometer at different points. We're going to test at the plinth, at the platter, and then we're also going to see how it does coming through the cartridge itself. So it's not supposed to be scientific. This is just for fun. So hang in there. It's going to be about 15 minutes and we'll jump right in. This is not my idea. I was watching YouTube one day and I came across a review by Francisco del Pozo. Actually, the review was by Danny Corvelli, and they went through great lengths of doing a very similar exercise where they put a transducer on the floor and they measured vibrations at different spots, and same with the EMF. But that video is in Spanish and I really dug it, so I thought I'd kind of recreate it and sort of do an homage to that video. And thanks you guys for doing that one. I'm going to link below in case some of you guys speak Spanish. It's a long video on the SL-1200, definitely worth a watch. So in essence, we're doing this for three distinct reasons. One is to illustrate the capabilities of the SL-1200 and the 1500, to compare it to each other and see why it's often worth the price difference, which is quite substantial. To bring attention to this topic, I see a lot of turntable manufacturers that essentially just put a motor and an arm on top of a plinth and call it a day. There's very little effort going into the isolation, and it has to result in some performance deficiencies. And thirdly, to be quite frank, to sell more turntables. We love Technics. We're fully on board. We've sold a ton of them since we've become a dealer, and we're really enjoying the process. So, if you guys are in the market for a turntable, please do consider us. So I realized there are many places you could buy Technics turntables from, but I'm going to illustrate a few reasons why I think, obviously, that you should give us a chance. First of all, our expertise. Go to our website, go look up either the SL-1200G or the GR2, which is a new model, and look at our calibration process, which is really available to anyone that's either buying a cartridge from us or supplying your own cartridge. Go look and see how much effort and energy we've put into coming up with a really detailed way of calibrating these turntables to get the absolute most from them. And we've got two processes for calibration. One, you can pay us to do our 12-step, but if all you want is some basic mounting and get up and running, we have that, and we do that for you free of charge. Secondly, customer support. I get calls from people all the time that have bought Technics turntables from other places, and they've been abandoned. They've either struggled with the setup or some of the final adjustments, and the retail has just given up. So yeah, give us a chance to demonstrate how much effort we'll put in making sure that you arrive, or one of these arrives at your place working brilliantly. I want you to check out our channel for other videos we've done on the Technics lineup. We've got an excellent video review on the SL-1200G. I'm going to put links below. I've got another review for the 1500C. We've got this cockamamie video where I put a $17,000 cartridge on a 1500C to see what kind of performance we could get out of it. And I also have a video coming on the GR2, which has been a little hard to get a hold of, but as soon as I do, I'm going to pop one of those videos on for you. Not just a review of the GR2, but comparing it to the SL-1200G. All right, let's go over the equipment we're going to be using today. The desk is just one of these simple motorized desks with a single top that is suspended with a long cross brace and fitted with a bunch of grommets. So the top is pretty well insulated or isolated from the base. The turntables, here we've got the venerable SL-1200G from Technics, my absolute favorite table nowadays, and the entry-level 1500C, which retails around $1,300. Back to the 1200, that retails around $4,200. The main focus is this actuator here. This is a linear actuator, or essentially a speaker that is mounted to a metal plate, and I've coupled it to the table with some clamps so that as this vibrates, essentially the entire surface is going to vibrate with it. It is powered by one of these amplifiers, this little digital amplifier that came with it, and this was all the two pieces were part of an in-wall speaker system that we had no use for. So it's really the perfect device for this application. It's got quite a bit of a weight in here, so it can really excite the table quite a bit. So that would have been an in-wall system. This would have been behind sheetrock or wood or something as an invisible speaker. Now we're going to feed a signal from this very simple function generator. This allows me to choose the kind of wave that we want. We're going to use a sine wave and the frequency. And also I've got some amplitude here and the ability to turn it on and off. And that's what you hear now. You hear this thing vibrating at 40 hertz. All right, feeding out of the turntables, we've got a Brooklyn bridge, which is a DAC that has a really nice phono input, super flexible piece. And then I've got an oscilloscope here because later we're going to feed the signal. We're going to create some vibration and we're going to see if we can actually hear that signal coming out of the cartridge if it makes its way all the way through the system. So that little very simple oscilloscope will do the job. And then lastly, I've got this really cool electromagnet detector. This essentially detects EMF or electromagnetic interference. So we're going to probe these two turntables and see what kind of isolation capabilities they've got for the electronics that are in them. All right, so that's the entire setup. I do have a set of headphones there and not much else. I've got this app running on my iPhone. I'll put a link to it below. It's a pretty simple app, but it does have, it leverages the accelerometer that's built into the iPhone, which happens to be an incredibly precise and sensitive piece of scientific equipment. So this software essentially taps into that accelerometer and is able to plot magnitude of vibration in 3 axes, X, Y, and Z. So we're going to be using this to essentially record what kind of vibrations we see coming through. I'm going to press play right now. It normalizes. It takes a bit of a second to react because it's processing quite a bit of information. But if you see, if I tap on the phone or on the table itself, it's incredibly sensitive. So a few disclaimers before we jump in. Guys, this is not a scientific experiment. This is just an illustration for fun. We're comparing 2 turntables. We're going to use some instruments to visualize things. We're not measuring absolute anything. Nothing here is calibrated. It's really just a fun illustration. And I'd really appreciate it if you could leave a comment below. I'd love to hear from you guys. I love when people chime in and tell me what you think about the experiment, your experiences with Technics and other turntables, and what cartridges you're finding to work well these days. So please do leave a comment below. It really helps promote the video. I really appreciate it. All right, so the target frequency for today is going to be 40 hertz. A lot of experiments of this nature tend to use 60 hertz, but it's a little bit outside of the range of this application. So I don't think there's much of a detriment running this at 40 hertz. Now that's a frequency that within the auditory level, humans hear 40 hertz, we feel it, in the music and especially if you have a subwoofer that's pumping out bass, that 40 hertz is going to go ahead and transfer itself, through the furniture, through the air, into the turntable. So I think it's within a reason to test with 40 hertz. The first test we're going to do is essentially measure the table itself. So let me talk a little bit about the setup because I've tried a few different configurations. I wanted to be fair for the comparison. So I essentially put the turntable's mirror image so that having the actuator in the middle essentially excites the table equally, and both turntables are subjected to the same forces. So that's why you see everything right down the middle. So I'm going to go ahead and take a measurement here. I'm running 40 hertz, and as you can see, we're quite a bit off the scale here. This is my frequency from 5 to 50 hertz, and then the amplitude is sitting right here. And the amplitude and the measurement and the units is not that important because we're just using it as a comparison. We're not interested in a scientific measurement. We're interested in essentially comparing. So as you can see, 40 hertz here is pretty high off the scale. If I measure the same thing on this other side, turn on the generator. Once it settles down, it's just about the same thing. So we've got a little bit of a 20 hertz resonant frequency here, which is very common. And if I play with the table, I can get that to be a little bit off, but essentially the amplitude is the same for both here. So now I'm going to go ahead and take a reading at the 1500C. Now this is a turntable that's very, very well built. It uses 3 layers, uses an acoustical damping feed, sub chassis, top chassis. It's pretty heavy for a turntable in this price range. And we're going to see how it does at absorbing those vibrations. So I'm going to go ahead and, one second, in the wrong order. I'm going to pop this on here. I'm going to let it settle down. And you'll hear it when we're back on. So you can see we're just about reaching the top graduation, which is 0.08 meters per second square. So it's taken some of the vibration out just from the mass of the chassis and the construction of it. And then if we're moving on to the platter, depending on the position exactly, we get to about 0.18. Now let's compare that to the 1200G. Now the 1200G is quite of a heavier turntable. We're talking about 40-something pounds. It uses 4 different sort of layers on the plinth, top with a 10mm aluminum plate, and also the elastomer. The elastomer within the feet is highly engineered. These are metal feet versus plastic on the 1500, and that elastomer, a lot of attention has been paid to that to ensure as much isolation as possible. So let's get a reading again on the surface of the table, which is off the chart obviously. Now let's get a reading here on the plinth. You can see it's already lower than almost less than half. And then let's move this on to the platter itself. Let me pick up this side here. And then sure enough, on the platter itself, it's barely registering. You can just see a tiny little bit there. So quite a bit of isolation. Now you may argue, well, it's the mat. You know, we're sitting on a rubber mat. So let's go ahead and see what it does if we lay the instrument right on the brass plate. So a little bit tiny more, but it's still pretty impressive. Somehow, get a good shot of it. Somehow between the plinth and the platter, they're able to take out quite a bit of vibration as well. So it gets incrementally better. Now, I've also wondered, let's see if we can get a measurement at the tone arm. This is going to be tricky. I'm going to have to kind of balance the phone on it. See if maybe, I'd love to get a reading here at the suspension point. Now, this is the area where like a turntable like the Lin LP12 will shine. On the LP12, they've got essentially the platter and the tone arm coupled together and spring-loaded. So they sort of move together, so any isolation would be benefited from on both. On the SL-1200, they don't. Everything's essentially bound to or coupled to the plinth. All right, so a little bit higher than the platter itself, but still pretty good, pretty impressive. Now, a far more useful comparison would be to compare the Technics to, let's say, a standard turntable within that price range. Let's say a VPI or a Riga. Essentially, these turntable manufacturers, they don't put a lot of effort into, or as much effort as Technic does, into the actual chassis itself. Now, I've mentioned before, this, for example, has 4 layers. So we've got, 3 or 4 different exotic materials. Well, not exotic, but we've got 3 or 4 different materials that add up to about 40 pounds in 3 different structures. So quite a bit of effort goes into both turntables. Now you look at some of the, like a Clear Audio or a Riga, now you were talking about essentially a piece of MDF with some rubber feet and then the tone arm and motor directly bolted onto it. So they're going to perform much worse than these two will. So for comparison's sake, I'll try to swing back with another video comparing once I get back to the shop where I have access to more equipment. I'll try to repeat this exercise, comparing it to, sort of rudimentary turntable. I've set up for part 2. So I've got a Ortofon red moving magnet cartridge going out of the line output. I'm not going through the preamp built into this thing, so I'm going straight into the oscilloscope. And I've got the same setup here, 40 Hertz going to the transducer. So we're going to try to see what sort of vibrations make it up to the cartridge. So as you can see, if I spin the record, I've got pretty high gain set to this. Actually, it's not going straight to here. We're going into the Brooklyn Bridge. I need a little more gain coming out of it. to max out the scope. So it's going into the Brooklyn Bridge, into the phono input, moving magnet, and then into the oscilloscope. So you can see there. And if I tap on the record surface, it's quite sensitive. If I tap on the plinth, quite a bit more. And let's see if we see the 40 hertz make its way through. Indeed. So I can feel just the slightest vibration on the plinth, and even less on the record surface itself. Now let's switch over and see what this looks like. Try to memorize this sort of setting here, and let's see what it looks like on the 1200G. Move the connections over, install the same exact cartridge, lowered it on the record, same place. Let's look at the oscilloscope output. Same sort of. And let's turn on the 40 hertz. So we can see quite a bit less. I would say it's probably about 30–40% less of what's making it up to the entire system. So now vibrations coming through the table into the plinth, picked up by the cartridge, phono preamp, and then into the oscilloscope. So I'll try to provide stills of both side by side so we can compare them. All right, for the next bit, we're going to try to measure the EMF, or the electromagnetic interference, from these two turntables. Now, I have to power down almost everything on this workbench because this thing is incredibly sensitive and it picks up just about everything. So all the equipment's been turned off. The only thing that's got power right now are both turntables, as you can see by the lights. And we are going to set this to produce a sound. That will be a little easier for you guys to gauge it. So as a reference point, if I put it here on the coffee table, I'm down to 3. So there's no electronic interference whatsoever here, or electromagnetic. I'm going to go ahead and place it in a couple of different places. First, near this corner here, where, as you can see, we're hitting about 41, and I think the scale is volts per meter. Not quite sure. If you know, please do leave it in the comments. But again, this is just a reference point. We're not interested in the empirical value or the measurement. It's really just comparative. So we're seeing about 63 there. Here where the power supply lies is going to be a little quieter at 21. Give you a reference point if we go anywhere near the power cord. We're going to max out there, about 130. And then over here where the controls are, it's going to quiet down to about 24. So essentially the most important bit is right here. And it's pretty quiet at 21. As you can see, every time I grab it, it starts making noise. Probably because I'm holding a camera. Let's check this out on the... So let's put the sound back on. Okay, here we go. So about 20, about the same as the other one. It's dropping a little bit. Down to 17. Over here where all the buttons are, it's even more quiet. Now we're down to 4. And this corner that was pretty noisy on the 1500C is also down to 4. So reference, anywhere near the power cable, we're going to max out again. And then let's look at the actual top of the tone arm. We're near it. Pretty low as well. So we're picking up quite a bit more. So now there's no way around it. I mean, this metal top at 10 millimeters worth of aluminum has a lot to do with this sort of isolation. This is also a cast aluminum, but a much thinner gauge. And of course, the way the electronics are mounted and treated. I've noticed another thing on the 1200 is that the power button is a true power button. It actually, I'm almost certain that the power comes in through and through the power switch. So it's actually completely off at this point. While on the 1500C, it uses probably some sort of regulated power supply that it goes into just standby mode, because there is some residual noise on there. So it's just always waiting. There is some residual voltage within the power supply. So again, this is not meant to be scientific. This is just to give you guys an illustration of the performance of these two pieces compared to each other. All right, so in my opinion, the job of a turntable is to essentially not get in the way of the cartridge. All of the magic and all the detail comes from a cartridge itself. The turntable's job is to not hinder that performance. And of course, it's also a big part of the calibration. If a turntable isn't calibrated properly, you're just not going to get all the potential out of a cartridge. And that's what Technics does so well. It spins the record, it spins it incredibly accurate, without belts, without nonsense, without noise. And this arm, which has been evolved over decades and decades, it's a pleasure to work with. We absolutely love calibrating them, you know, from the VTA, the anti-skate, and the tracking force. It's just a dream to work with, and we really enjoy it here at SkyFi. Wasted another perfectly good 15 minutes of your time. I appreciate you guys watching. I appreciate the comments. I really appreciate a like and subscribe. And check us out at skyfiaudio.com. These turntables come in and out of stock all the time. If you want one, reach out to us and we'll put you on the list. Thanks so much.